So we learned that if we combine two random variables x and y by adding their values, then the expected value of that total t would just be the sum of the expected values of the means of each of those individually. So it stands to reason that if we have random variables x and y and we're combining them by subtracting, taking the difference, x minus y, so subtracting each of the outcomes, then their expected value or mean would be the difference between those. So when we add random variables, the mean of that sum is the sum of the means. And when we subtract random variables, the difference or the mean of the difference in those random variables is going to be the difference in their means. And just like before, in general, we can extend that to more than one random variable. So it doesn't just have to be one. If we subtract multiple random variables, then we would just subtract their differences. So say, for example, we want to know how many fewer passengers, D, will Pete have than Aaron on a randomly selected day. So we're defining a new random variable, D, and that random variable, D, is going to be how many fewer passengers Pete more or fewer passengers Pete will have than Aaron. So we're taking the amount of passengers Pete has, which is X, and subtracting the amount of passengers that Aaron has, which would be Y. And so the mean or the expected value of that difference, D, would be the difference of the means. So the mean of X minus the mean of Y. The average number of passengers that Pete has, 3.75. Minus the average number of passengers that Aaron has is 3.10, which gives us 0.65. In other words, what we're saying is that on average, or on a typical day, or randomly selected day, Pete will have 0.65 more passengers than Aaron. We know that on a randomly selected day, the number of passengers, X, on Pete's tours is anywhere from 2 to 6. And the number of passengers, Y, on Aaron's tour will be between 2 and 5. So the difference in the number of passengers, X and Y, would range from anywhere from -3 to 4. In other words, if we took Pete's smallest number of passengers, 2, and subtracted Aaron's largest number of passengers, 5, the smallest difference would be -3. So the minimum would be -3. In other words, we're saying that the minimum is that Aaron would actually have 3 more passengers than what Pete did. But if we look at that on the opposite end, Pete could have up to 6 and Aaron could have as few as 2. So the maximum difference then would be Pete's maximum amount, 6, minus Aaron's smallest amount, 2, which would be 4 passengers. So we could have anywhere from Aaron having 3 more passengers than Pete, to Pete having 4 more passengers to Aaron. And so if we found the range of D, we would have our max 4 minus our minimum -3, which is 7. Notice that this is the same result that we got whenever we were looking at the sum of X and Y, 7. It turns out that regardless of whether you're adding or subtracting, the range of T is always going to be the range of each of the random variables. So the range of the total is the sum of the ranges of each individual. So it's the range of X plus the range of Y. In other words, whether we're combining by adding or subtracting the random variables, the range will be calculated the same way by simply adding the ranges of both. If we follow the process that we used earlier to come up with a probability distribution for D, where we have X minus Y, we could use our probability rules to calculate the probability of each of the possible outcomes from -3 to 4. And again, it looks like I left off a decimal here in this last one. That should be 0.015. In other words, the probability of Aaron having 3 more passengers than Pete is 0.015. The probability of them having the same number of passengers would be 0.235. The probability that Pete would have 4 more passengers than Aaron is 0.015, and so on. So that's our probability distribution for each of the possible values for the difference. So what I'd like for you to do is I want you to take a minute and use your calculator and this probability distribution that I've given you for D, the difference between the number of passengers, to calculate the mean, the variance, and the standard deviation of D. So take a few minutes to do that, and when you're ready for the answers, come back for part 4.